move forward now with the guys from NASA and all the fancy equipment out in the hallway. Mark, we'll let you off the hook.
Yeah, really.
For now.
They're going to put me on the ground.
Easy.
Good evening, Mr. Klein. Ladies and gentlemen of the board, we will, just waiting for the projector to come up, and members of the community. My name is Fred Bauer. I teach at Council Rock High School South, and I am very proud to be here tonight and presenting to you again the NASA group. Our students have been working again all year long. They have worked closely with NASA. I am not going to take up the time. I am going to turn it over to them directly. They will introduce themselves and let you know about the project that we worked on this year.
Hi, my name is Samuel Cluff. I was our project manager this year.
Hello, I'm Jonathan Bauer, and I was in research and development.
Hi, I'm Julie Tamir. I was also in research and development.
My name is Preissman. I was head of PR and also in research and development. So what is HUNCH? HUNCH stands for High School Students United with NASA to Create Hardware. Now there are four divisions of HUNCH. We're in the Extreme Science Division or program, and this is the fourth level of HUNCH, also one of the highest. What that means is NASA comes to us at the beginning of each school year and they tell us to ask a question. And we decide what that question is, and then we pursue that question and design, test, self-fund our experiment, and build it, and then eventually head down to Houston, Texas, and fly our experiment on the Weightless Wonder, the C9 zero-gravity plane.
So this is just a small list of how HUNCH and Council Rock interact with each other, whether it's in the science department, technology, the engineering, or the mathematics. Just flip it right through. This is just a few ways in which we interact, or our students interact and learn with STEM, which is something that I'd like to say we push very heavily in our district.
So this year for HUNCH, we decided to focus on VIBE, which is called Vibration Isolation Box Experiment. And our focus was to create a harboring device that would be able to bring fragile cargo up from Earth to the International Space Station. And we wanted to create an incubation chamber also so we can bring embryos up into the International Space Station to see how they develop in zero gravity. So we wanted to make a test chamber that could check the temperature, humidity, carbon dioxide, and oxygen.
So we created two model systems, what we call our spring system and our memory foam system, and this is one of the systems right here, just so you have an idea of relative size. What this is we have 4 springs or 4 blocks of memory foam that go on each side of the internal box. These are used to dampen the vibrations from what would be considered the rocket flight to the ISS, and it's to reduce the damaging vibrations to the internal cargo. We also had 3 vibration sensors in each box so that we could test and view the vibration that occurs on the X, Y, and Z axis, and then 3 outside so that we could have a control set for our experiment to compare our data to.
So we went to Houston and we tested our experiment on NASA's microgravity plane. And we found our memory foam box to reduce vibrations by 22%, and we found our spring box to reduce vibrations by 61%.
So this is not meant to be just a one-year project. This is meant to be a multi-year project. This year we focused solely on the anti-vibration portion of our experiment. We're hoping next year to be able to expand this project into a full embryonic development incubator system. But this project can also be expanded into a different direction of a protective item transfer, because it can not only reduce the vibrations of an egg, it can reduce the vibrations of any fragile cargo.
as a fringe benefit from last year's experiment, we studied capillary effect in zero-G environment. We were contacted by NASA to continue our program, and we were put in touch with and asked to participate in the SELIR experiment, which is held out of Portland State University. They just installed a drop tower for testing zero gravity and capillary. NASA was so impressed with our experiment last year, they recommended us to their site. We've been working all year long on designing capillary environments and testing them at Portland by basically sending our experiment design specifications out to them. They recreate our experiment in their drop tower and run our experiments and send us the live video feeds back or the recorded video feeds, plus any data analysis that we're asking for. They've been very happy with us. They have invited us back again next year. We're 26 seconds short, Mr. Klein, so we're okay. If there are any brief questions, we will be happy to answer them. But I can tell you this. If I eliminate the entire experiment, if I eliminate what these students have done, and all I tell you for the next hour is their experience and how they made us so proud down there, you would not believe how well that these students interacted with astronauts on a one-to-one basis, engineers from NASA. They were invited to facilities that none of the other 16 teams that have been accepted to across the country were in. So these students got a behind-the-scenes tour, behind-the-scenes experiments with astronauts and with the flight engineers in Houston that is beyond belief. You should be very, very proud of them. And there are 47 on the team. 2 of these were on the flight crew and 2 were on the ground crew, which without the ground crew, the flight crew could not have gone up. Thank you very much for your time.
So Sam, I know you're a senior on the team. Who else is a senior on the team? Could you just tell? Jody, I didn't know you were a senior. Just like yesterday, you were a kindergarten kid. Tell me where you guys are going next year.
I'm attending the University of Alabama for a double major of aerospace engineering and physics.
I'm attending Drexel University for mechanical engineering.
I'm attending the University of Vermont for mechanical engineering and material science.
I'm attending Penn State University for mechanical engineering.
Fantastic.
Hey, could I ask a
Congratulations.
question? I want to put you on the spot, right? You've gone to all this work. So thanks for this diagram. So I was looking at it. There's the vibration sensor you were describing. So did you get a chance to find out how that works? What's in there that makes it sense vibration?
Sam, if you're going to talk, just make sure you get a microphone or they won't catch you
Okay.
for posterity.
So, actually, I'll come over to you for a second. Because we have the actual sensor right here. So this is what the sensor looks like, and as you can see, it's a small little panel. And so what happens is, as vibration occurs, the panel moves up and down in a purely one angle of axis, and so it's called an analog sensor. And so what it does is just picks up the up and down motion, records it, outputs a number for us. So we took those numbers over, and it took 5 numbers a second. It would take 5 readings every second. We took those numbers through the entire 90-minute flight, and we graphed them up there purely based on the change rate, and it came out as a graph that showed multi-axis. Then we compared them to our control data and just received our results.
Exactly.
It's not rocket science. Oh, I'm sorry.
Are your springs
And now for the rest of us, please.
Are your springs tunable so that in second iteration or third iteration you'll be able to account for the periodicity of the vibration by tuning the spring?
Well, we don't have tunable springs. We had one style of spring. We tested a few different springs. Actually, the springs were our second, I'd like to say second generation of 5. The first generation used what we called silicone gel mounts, and they had a K value that was too stiff to actually dampen the vibration. These springs we found in a Hasbro toy to fit different sized vibes. Sorry, I should have been talking to the
Sandy, I
microphone.
think you've got a pretty dynamic voice. It might carry. I think it's okay. Good.
Any other questions? Okay, again, thank you very much for the
I
privilege
can't
of
tell
coming
you
here
how
and speaking.
impressive they are, Craig. Congratulations.
Yes,
Fantastic
sincerely,
stuff.
great
Our
work.
website,
For people
Sam
who are
Preissman.
seeing this at home, outside the boardroom was actually a display table with all of the different information and equipment that they used as part of their NASA HUNCH program. And you kindly called it, what, the zero-G machine, but there's a more interesting name for it called,
We like to call it the weightless wonder.
okay, but it's called other things, right?
Yes.
Good. So thank you very much for bringing all that information to us, too.
One last question. Students flew this year. The
we took 6 students down, 4 students flew. We were the only team to have 4 students that were asked to fly. All the other teams were 2 students, and there was another team that was 3. But these guys, as NASA likes to see, prepared for worst-case scenario. So in doing so, we were only supposed to fly 3, but because we had people that were under flight status, they filled in on a slot that was available at the last minute. So they really did a good job preparing everything for the flight and for the experience.
And thank you for your leadership in this program.
Absolutely.
It's a point of pride for the district, really.
It's my pleasure. We're hoping to be able to continue this for a long time. Thank you.
Congratulations.
Thank you.
Well done.